We've measured our features and are now ready to apply GD&T. While an initial coordinate system may be helpful, be aware that in the process of evaluating each GD&T control, the part will be realigned to the datum specified in each feature control frame. Geometric dimensioning and tolerancing defines and communicates part function and engineering tolerances. The GD&T mode in our software greatly simplifies inspecting the engineering drawings. Callouts address form, orientation, and position. For form and orientation, nominal information is not entered because the software knows that with form, a feature should be perfectly shaped, and with orientation, the feature should be perfectly oriented with respect to its datum. Perfection is zero deviation, so the nominal is zero. However, for positional tolerances, we will need to enter nominals. This information will be size, position, and orientation. We have to know what something should be before we can quantify deviations. If you have CAD, that information is automatically extracted. If you're working from prints, you'll have to key in the information. Ready to begin? We have our measurements, so we now go into GD&T mode, either by clicking the GD&T mode command on the home ribbon, or by right-clicking a selected feature and clicking GD&T mode in the context menu. Notice all selected features are automatically added. To add more features, click Include Features on the GD&T ribbon. To keep a clean workspace, bring in only the features you'll be working with. Double-click a feature to open its GD&T callout, which will contain any information already entered. Note on the left is the symbol for circularity. As we click through, you'll notice the form callouts that were calculated by default during feature measurement were automatically appended to the GD&T. Changing tolerances is easy. Simply click in the box and type the new tolerance value. Now within the feature information screen, you'll see that the new tolerance has updated. Also notice the nominal for each feature has also been automatically pulled in. No datum is required at this point because the feature is comparing the points measured to the feature itself. For orientation, however, we need one of the features to be a datum and the other the feature of interest. For example, here we can check the perpendicularity of two cylinders. We'll make the through-hole cylinder the datum by selecting it and applying a datum letter. You can choose an existing letter or type in a new letter. Next, choose the type of datum. In our example, it must be a linear datum. Notice the letter has been applied in the feature list and on the CAD view itself. In our example, it's difficult to see, so we'll increase the font size. Now we can see that we have the backside view of the letter. Let's turn it round, then click the front-facing icon, which will make the datum letter face front and horizontal no matter the screen orientation of the part. Continuing on, we'll add the right-hand end cylinder to look at its perpendicularity compared to datum F. To do so, select the right-hand end cylinder and click Perpendicularity in the ribbon. The feature control frame opens. Choose the datum to compare it against, and notice the feature control frame matches the print, but the level of detail can be increased in the label. Click outside the control frame to close it. Under level of detail, you have several options. simple with tolerance bar, or full detail. Then repeat with the other features. In this example, our concentricity is out of tolerance. Again, nominals were not required, nor was a coordinate system, making this very easy. In fact, let's create a coordinate system. If we close the GD&T mode and create a coordinate system, we'll see the coordinate system trihedron locates itself at our chosen origin feature and is oriented through the other coordinate system features we selected. To apply true position, we need to enter nominal information. Go into the feature information screen and click your features checkboxes to make them active. Enter the nominal information. The elements of a feature must be active to change the information. Deselect the elements after changing them if you don't want to report them. To enter the nominal vector information for the orientation, select just one component of the vector. The display allows you to enter all three from a single nominal. If using planes as the datum, as we are here, you'll need to enter the nominals for each datum plane. For the right-hand end plane datum, the only coordinate that is really required is the x value, the nominal distance of the right end from the origin. Because the orientation of this plane is perpendicular to the plus x axis, the nominals for the vector are 1, 0, 0. For the cutout plane datum, the only coordinate that is really required is the y value, the nominal distance of the cutout from the origin. Because the orientation of this plane is perpendicular to the minus y axis, the nominals for the vector are 0, minus 1, 0. If you get a GD&T result that is much higher than anticipated, check that the positive and negative signs are correct on both the coordinates and the orientation. Now we need to know the nominals for the 12 o'clock circle in our example. We know this should be at 0 on the x and z axes and the correct distance along the y-axis. The diameter and its tolerance from the print are necessary if we're going to calculate the material condition for the feature, and finally we need to know the vector of the circle. If any of this information is missing, the true position will not be calculated correctly. Now we'll return to the GD&T mode, bring in those features and assign them as datums. To apply position to a feature, highlight the feature and click the corresponding feature control symbol on the ribbon. Here we selected a feature of size, which gives us several options: maximum material, least material, or regardless of feature size. The software will automatically calculate the appropriate bonus. The positional control can be against the active alignment or against one or more of the datums. Any positional control can be fully constrained by the active alignment or relative to the specific constraints of the particular datum alignment called out in the datum reference frame. In this case, active alignment will use our coordinate system, which will give a different result to any other datum alignment we specify. This new methodology for GD&T alignments in the software eradicates the need for workarounds and temporary alignments that were necessary in the past. To see what happens with datum features of size, let's use some cylinders in the datum reference frame and check the position of a different circle. As before, highlight the circle and select position. Material condition can be applied as necessary, and then the datum reference frame specified. Notice the red outline. This means we haven't provided enough information for the software to perform the calculation to the specified datum reference frame yet, so the active alignment will be used. In this case, it's because the circle we added didn't have nominal information. Due to its position on the bolt circle being defined by two distances and an angle, the coordinates would ordinarily have to be manually calculated. To get around that, we can briefly change the active coordinate system type from Cartesian to cylindrical. This now allows us to define the circle's position on the bolt circle using an angle relative to the x-axis and the two distances defined by its height and the radius of the bolt circle. Finally, we can enter the diameter of the circle for material condition calculation. And when we switch back to a Cartesian coordinate system type, we can see the nominal coordinates have been automatically calculated. And the red box is gone. When we add our datums of size, we see that the dialog is modified to allow us to evaluate datum shift by mimicking the GD&T control on our print and selecting the relevant material modifier. This looks at the nominal and actual information provided and puts a number to the functional wriggle room that allows a part to assemble to its mating component, as they can shift relative to each other as holes get bigger and pins get smaller. In our case, the part passes. You can see using prints can be a time-consuming process. If you have access to CAD, however, your timeline will drastically compress. To demonstrate, we're going to set the coordinate system back to world and alignment to none. From here, we'll import the CAD and realign the part back to the CAD. Now we'll see that aligning the coordinate system to CAD automatically extracts the nominal information. It even extracts information from any point cloud scans. Another new feature in the GD&T mode is creating patterns. In our example, the rest of the bolt circles. Select all the features that make up your desired pattern and click Create Pattern on the Patterns toolbar. The pattern is created. Select the new pattern and click Position on the toolbar to apply position to the pattern as a whole. Select Material Modifier as appropriate and assign the datums as required. With the CAD information, there's no extra work getting information in. All nominal size, position and orientation information is provided automatically. The tolerance zones for each circle center point in the pattern are fixed relative to each other and constrained as a group, but the position of each circle is evaluated individually to that group constraint. In our example, we don't meet specification. The ability to manipulate and capture a snapshot of the screen is also a valuable feature. Labels can be moved to the same positions as the drawing. Once you have them arranged just so, click the Capture command. The view data is shown under the feature list. You can then position them however you like in the report. In the regular mode, let's cut cross sections through the point cloud and apply profile tolerances. Define an offset and the distance between sections. Adjust point distance filter to ensure the software searches an appropriate distance from the CAD model for points to be evaluated. Now when we hide the point cloud, we'll see the cross sections we define. Back to the GD&T mode. Bring the cross sections in and apply profile of a line to each. Note that the profile commands will only reflect the active alignment. Apply profiles to the other sections and notice they too are calculated to the active alignment. Profile of a surface can be applied to the point cloud feature that the sections were cut from. Reporting is made easy by simply adding the features, views, and patterns you desire. If you don't like the main overview picture, you can easily return to the main screen and recapture the view. Errors are easily corrected and updated. Items can be renamed, dragged and dropped to different positions in the report and reviewed in the quickly updated preview window.